Okay, today we are going to look at our last lesson for the semester, 21.3. We're going to use some special factors to solve equations. So if you remember back when we did multiplying polynomials, we did some special cases where we had something like x plus b squared, all right, or we had x minus b squared. When we did something like that, it gave us some special cases, some special products. This time we are going to undo that and we are going to factor from a standard form quadratic to get back to one of those special cases. All right, so these are what's called a perfect square trinomial. They take the form where we have a squared plus 2ab plus b squared, right? And then they factor into a plus b times a plus b, or a plus b squared, or a minus b squared. So if you look at the term, it's got to have twice as big in the center. It's that special case that we looked at before. If it's positive here in the center, then it's positive here. If it's negative here in the center, then it's negative in the square. So when we look at a couple of cases, these are some big ones or some different ones, but we have like x squared plus 6x plus 9. Now 9 is the same as 3 squared. X squared is the same as x, well, it's x squared. So 6x is 2 times 3 times x. So that gives us, we know it takes this form, the 2ab in the center, and we can write it as x plus 3 squared. Now, this can change if we have a different constant in the front, if we have another variable associated with it. Some of these can get big and messy. We're going to try to keep it a little bit simple for what we're doing here. All right, the other one I want to kind of look at here is this one. If we have x squared minus 10x plus 25, 25 is 5 squared, x squared is x squared. So negative 10x is negative 2 times 5 times x. So we know that that is in this form, and it's minus, so it's going to be x minus 5 squared. All right, let's look at another example. So we can kind of rewrite this a little bit. Remember that out front is that little 1. So when we look at this first example for this perfect square trinomial, 64 is the same as 8 squared. 16 is the same as 2 times 8 times 1 times x. That 1 just comes from the number that's in front of x. So we can know that this is going to be x plus 8 times x plus 8. So that should make it fairly simple, fairly quick. So the factored form, x plus 8, or we call it x plus 8 squared. Okay, another example. I'm going to do this, 4x squared minus 12x plus 9. So when we look at that, we can kind of think about this. This is the same as 2 squared times x squared. And then we have 12 is the same as this times 2x times 3. So 3 times 2 is 6. 6 times negative 2 is negative 12. And then plus, this is the same as 3 squared. Notice that both the first and the last piece are squares. So we look at those and we can factor this into 2x plus 3. Oh, sorry, that should be minus 3 because it's negative in the center. 2x minus 3 times 2x minus 3. Okay, since it's 2x squared out front, this is going to change a little bit. Instead of it just being x in the front there, we'll have a 2x. We can also rewrite this as 2x minus 3 squared. All right. And our next one is when we're looking at differences of squares. We have a squared x squared minus b squared when that equals 0. This is one that when we looked at that before in the special cases, it went in that form a plus b times a minus b. So when you have a difference of squares like this one should be quick and easy to kind of think through and write out. So this is x squared minus 7 squared. So what that means in a factored form, it'll be x plus 7 times x minus 7. One of them will have to be positive, one of them will have to be negative. That's what gets that center term. There is no x term in the center. That's what gets that second term to cancel out. So the next one, if we look at part B, 49q squared, that's the same as 7q squared minus 4p squared. So that's the same, 4 squared is, or 2 squared is 4, so this can be rewritten as 2p squared. All right, notice it has to be a difference of squares. It has to be subtraction. So now when we factor this, 49q squared minus 4p squared, we can break that apart into 7q plus 2p times 7q minus 2p. Remember, one will be positive, one will be negative. And then we can leave it like that. That is factored and done. All right, you have your last assignment that's posted with this, so go ahead, get that done, get it turned in so you can wrap everything up. And then we'll see you in the next Zoom.